Okay, this is homework 5.5, adding and subtracting rational expressions. This is day number 2, so this is where we were dealing with binomials in the denominator. This is going to be number 10. And as I go through this problem, I'm going to just go through the steps that we talked about in class so that you can become familiar with how to deal with a rational expression that is being subtracted. So the first step says to factor the denominators. So what I'm going to do is I'm going to look at my first denominator and I'm going to factor it. And it looks like they have a 3p in common, and it leaves me with a p minus 5 for this first one. Okay, and I'm going to actually mark out the original denominator because I'm going to leave its factored form in its spot. So now my denominator, instead of being 3p squared minus 15p, is just going to be 3 times p minus 5. The second denominator, well, it's just going to stay at 2. There's nothing to factor with that one. Okay. Step number 2 tells me to find the common denominator. So I need to figure out what is my CD for this problem. And it looks like, according to the first fraction, everybody has to have a 3p and p minus 5. According to the second fraction, they need to have at least a 2. So this is where I have to do a little bit of extra work because I have a 2 and I have a 3. So I need to find the least common multiple of those two numbers, and it looks like the first number they meet up at is going to be a 6. So everybody's got to have a 6 in order to have a common denominator. And then I look and I say, okay, everybody also has to have a p, standalone p, and then that binomial factor of p minus 5. So in order for everybody to match, these are the 3 things that they must have in common. So now I'm going to go ahead and do step number 3, which is I need to multiply each fraction by what it's missing so that they can have a common denominator. Okay, so I'm going to deal with this first fraction here, okay, and what it needs to be multiplied by. Remember that I'm not using this denominator anymore. I'm using its factored denominator. And let's see, he already has the p minus 5. He already has the standalone p. The only thing he's missing is a 6. So in order to make that 3 be multiplied into a 6, it needs to be multiplied by a 2. Top and bottom. Okay. Now let's deal with the other fraction, and then I'll go ahead and multiply everything out. The other fraction, this one gets a little bit trickier because he only has a 2. Well, that 2 needs to become a 6. So I know that there's at least a 3 here. Okay, he does not have the standalone p, so he also needs the p. And he does not have this p minus 5, so he also needs a p minus 5. Okay, so that second fraction is going to have the most multiplication in it, and I'll come back to that in just a second. Let me slide this down here. Let's go ahead and multiply these out. The first fraction, I need to distribute the 2 to the 3p plus 2. So I end up with 6p plus 4 in the numerator. And in the denominator, the 2 and the 3 get multiplied together, so I get a 6, and then a p and a p minus 5. Remember that we don't actually multiply out the denominators, only the numerators. I'm going to bring down the subtraction symbol because I need to take away whatever's in the second fraction. Now the second fraction, let's go back up here for a second and look at this. Okay, I have 3p, which needs to be multiplied by 3p, which also needs to be multiplied by p minus 5. So I have 3 things being multiplied together, and I do need to actually do that multiplication. So what I need to do is I pick 2 of them, multiply those 2 together, and then multiply that answer by the last factor that needs multiplied. So I'm going to, for the ease of things, I'm going to multiply the 3p by the 3p. And I'm going to say that that is 9p squared. Okay? And then I'm going to bring up this third factor, that is a p minus 5, and say, okay, now I can distribute him and multiply. And I can say that this is going to equal 9p to the third power minus 45p squared. Okay, so those three factors, whatever order you multiply them into, this is what the numerator is going to be on my second fraction. So I'm going to, let's zoom out here, let's slide down here, and that's going to be the numerator here of my other fraction. And the denominator, well, let's see, the 2 and the 3 get multiplied together, so I get the 6 that I needed. The p stands alone, and then I get p minus 5. Okay, so that right there is probably one of the hardest steps, okay, of getting those fractions to have the same denominator. Now that they have the same denominator, I'm going to put them together as one big fraction. I know that my denominator is going to be 6p minus 5. Now in the numerator, I need to put it as one big fraction and combine like terms. So I'm going to start with, let's see, let's do the 6p. I have 6p and there's no other p to the first power, so he gets written down like that. Takes care of him. 4 plus 4, there's no other coefficients, constants in order to add or subtract, so it just stays a 4. But look at this, I need to subtract this fraction. So I need to actually subtract 9p cubed. So I'm going to subtract 9p cubed. And I actually need to subtract a negative 45p squared, so a double negative becomes positive and I get plus 45p squared. Okay? Now what I'm going to do, now that I have the tops all in one big fraction, is I need to simplify this fraction. So I'm going to rewrite it, okay? And I'm doing this in 2 steps so that you can see what I'm doing here. I probably would have done it in 1 though. Okay, so if you're comfortable doing it in 1, you can. I'm going to rewrite this in standard form. The highest degree I have is a p cubed, so I'm going to write the negative 9p cubed first, then the plus 45p squared, and the plus 6p, and plus 4. Now I want to look at this and I'm going to say, okay, do these things have anything in common that I could cancel out? This is kind of a big answer. Maybe I can make it smaller. Okay, that's step number 6. And negative 9, 45, 6, and 4 have nothing in common. They also don't share any p's because this 4 doesn't have any p's. So there's no greatest common factor that I could factor out to cancel out with like this 6p in the bottom or this p minus 5. So this is actually the final answer right here because there's no simplifying that I can actually do to this particular problem.